Hi, my name's Steve, and once again we're back with another maths challenge from the UK. This is the UK Intermediate Challenge from 2016. This is aimed at years 9 to 11, generally years 10 and 11, but anyone can do it at school age as long as you're not in sixth form. And it's a complete multiple choice test, 25 questions. They get increasingly difficult. I will tell you now, it is more difficult than you think it is for pupils aimed at that age, and if you are a student of that age, please use this as practice. I'll give you a few tips. I'll show you how I do this and do with the best we can do. The way it works is you'll notice down here you're going to get some marks for each question. So you get 1 hour to do it, so you get 1 hour to have a go at this paper. Questions 1 to 15 are worth 5 marks each. Questions 16 to 25 worth 6 marks each. However, once you get past question 15, you can no longer guess. In that if you guess, you're going to lose 1 mark if you get questions 16 to 21 and 2 marks if you get the last 5 questions wrong. So it is multiple choice, but I would suggest that you don't guess unless you're sure it's between 2 options, and then it's actually worth having a little guess if you're not sure. But generally the options they give you will be good, wrong answers. They will pick answers that you might get if you've done something wrong, so be careful. And don't worry if you find any of these hard, especially if you're a pupil at school, at the school age of this sort of thing. No, very few people, if any, will get them all right. I often get a couple wrong when I do this. I'll get a wrong answer or misread a question or something. So don't worry if you can't do questions. But we're going to have a go. We've got an hour to do the best we can. At the very end, I'll mark it. So if you want to have a go yourself, pause this video. The link to the paper is in the YouTube comments below. So have a look down there. And also, please follow me on YouTube if you want to see more of these videos, and follow me on Twitch where I do them live. So this is currently live streaming on Twitch. If I ever kind of stop and pause and talk to someone who isn't there, it's because my chat is trying to interact with me. But beyond that, we're going to go. We're going to look at the time. We're going to give ourselves 1 hour. It is 18 minutes past 5. Off we go. So question 1. What is the value of 6,102 take 2016? I hate takeaways, and I least 102 take 2016. You might be able to do this in your head. If you take off 2,000, you've got 4,102, and if you take off 16, you've got 4,086. So yeah, I'm not actually going to do that. I just did that in my head. Which of the following fractions is closest to 1? That is 0.125 away. Well, that's an eighth away. That's a 7th away. That's a 10th away. That's an 11th away, and that's a 10th away. So the smallest of these 5 fractions is 1/11th, which means that one is the closest to 1. How far are they away from 1? That is the smallest amount away from 1, so we'll go with that one. How many of these 5 expressions give you answers which are not prime numbers? So we're just going to work them out. 1 squared plus 2 squared is 5, so that is. 2 squared plus 3 squared is 13, so that is. 3 squared plus 4 squared is 25, that is not prime. 4 squared plus 5 squared is 41, that is prime. 5 squared plus 6 squared is 61, no, 25 and 36, 61. 61 is prime, so we think 4 of the expressions, apologies, misread the question, 1 of the expressions gives a number that's not prime, and it's that one there. Amrita is baking a cake today. Brilliant. She bakes a cake every 5th day. How many days will it be before she next bakes a cake on a Thursday? So this is weird. I can do this quite easily. How many days will it be? So for every 5th day, and there are 7 days in a week, 5 doesn't go into 7 effectively. There's no common factor. Apologies. They're what's called co-prime. So today, they did this challenge paper on a Thursday, I believe. If you go back to the date it was set, I believe it's Thursday in February 2016. So today, the day they do this paper is Thursday. So you've got to assume that in this paper, if you do this paper at a later date, that the day and the date is what it was at the front of the paper. So because 5 and 7 are co-prime, every 5th day, it will be 35 days before you hit a multiple of 7. Yeah, so basically it needs to be a multiple of 5 and a multiple of 7. I believe. I could work that out. I could just say, yeah, so because 5 and 7 are co-prime, you'll hit a different day every 5th day. So it's Thursday, and then 5 days later it'll be whatever, Monday, and then 5 days later it'll be Saturday, and then 5 days later it'll be Tuesday, and then 5 days later it'll be, you get the idea, Sunday, and then so on. And so because they're co-prime, you won't have a repeat day until you hit another Thursday. And you'll hit Thursday again in 7 attempts. So 7 5s is 35. You could sit down and work that out, but I knew it was 35 when I read the question, so I'm not going to waste time doing it. But you could sit there and work that out, I think. You could just count up in 5 days. But because 5 and 7 haven't got any common factors, you're not going to get any repeats until you hit the next Thursday. So you're going to get all 7 unique days. Modular arithmetic is pretty fast, yeah. Hi, Amiga. Yeah, so if I didn't know how to do that, I would potentially do something like that, Turtle, or I would just maybe manually do it out, but I kind of knew how that was going to work. When travelling from London to Edinburgh by train, you pass a sign saying Edinburgh, 200 miles. And 3.5 miles later, you pass another sign saying halfway between London and Edinburgh. So you've been travelling. Oh, I see. So I thought this was a time. 3.5 miles later. So 203.5 is the halfway point. So times that by 2 to get the full distance. So 203.5 miles away from Edinburgh. That's from Edinburgh. So in 3.5 miles, yeah, okay. And then we just double that, we get 407, which gets you the answer there. 1/3 of the animals in Jacob's flock are goats, and the rest are sheep. There are 12 more sheep than goats. How many animals are there altogether in Jacob's flock? My guess is 36, but let's see if we can do this. So 1/3 of X are the goats. That means there's 2/3 of X are sheep, and there are 12 more sheep than goats. If this is your goats and this is your sheep, then there are plus 12. But 12 is the same as an extra third, so 12 must be 1/3 of our total. So we know that if 1/3 plus 12 is 2/3, then 1/3 is also 12, which means that our total is 36. Have I gone wrong on that previous one? Oh yeah, I've done it wrong. That shouldn't, yeah, thank you very much. I've got this one wrong. I misread it. We're actually going to Edinburgh, not from Edinburgh, so it's actually going to be 196.5 times 2, which is 293. Yeah, I got that one wrong. That was a chat punt. Thank you very much, Semicircles, and thank you very much, Ignatius. I just misread the question there. In the diagram, what is the value of X? Right, so a couple of ways, there's lots of ways of doing this. We're going to work out this angle, which will allow us to work out this angle, which will get us X. This angle here is 285. And then to work out this angle, let's call this angle Y. We know that the angles in a hexagon add up to 720. So we know that 720 equals 285. This feels like there might be a quicker way of doing this. Plus 27 plus 23 plus 26 plus 24 plus Y. And 27 plus 23 is 50. 26 plus 24 is also 50. So that gets us 100. So we've got 385 plus Y equals 720. So Y is going to be 720 minus 385 is going to be 15. I've done something wrong here. I'm not going to get one of those answers. My guess is it's going to be 25. And the reason it's going to be 25 is 6 and 4 add up to 10, 3 and 7 add up to 10, and then whatever angle this is going to end in a 5, which means whatever angle y is going to end in a 5, which means whatever angle x is going to end in a 5. So I know it's going to be 25, and I've just done something wrong with my arithmetic here. 385, it's 325, there we go. That still doesn't work. 335, there we go. I hate takeaways. And 335 equals y, which means x is 25. I just did my arithmetic wrong there. What is the value of 2.017 multiplied by 2016 subtract 10.16 times 201.7? Right, we're going to say, I'm going to rewrite this as 201.7 times 2016. Subtract, and if I multiply this bit by 100, I divide this bit by 100, so that's 0.1016 times 201.7. And we can write that as 201.7 lots of 2016 Oh no, you have to multiply them both, apologies, multiply them both by 100, so that gets you 1001. There we go. And that works quite nicely. And that is going to be 201.7 multiplied by 1000. That gets you 201.7 multiplied by 1000. But I need to divide my answer by 100 because I've multiplied them both by 100 at the very first step, so it's going to be that one, I believe. Might be a more elegant way of doing that, but there's no way you're going to spend time working those out. The fact is that they've both got a factor of 2017, but just at the wrong sizes. You just need to modify them a bit. So what you do is multiply both terms by 100 at the start, and then divide your answer by 100 at the end. That would work. The world's fastest tortoise is acknowledged to be a leopard tortoise from County Durham called Bertie. In July 2014, Bertie sprinted along a 5.5 metre long track in astonishing 19.7 seconds. Watch out, Usain Bolt. What was Bertie's approximate average speed in kilometres per hour? Approximate, so we're going to round things. So we're going to say meters per second. So we were going to say it is 5.5 over 20 meters per second, which is the same as saying 2.75, 0.275 meters per second. Okay, and then we need it in kilometers per hour, so we're going to multiply this by, again it's an estimate, I could have maybe rounded the numerator as well, but if I'm rounding the denominator up, I should round the numerator up, so I'm going to round the numerator up to 6, and then this gets you 0.3 meters per second. And if that's 0.3 meters per second, in kilometers per second, it's going to be 0.0003 kilometers per second. And then multiply that by kilometers per hour to get hours, but from seconds to hours you multiply by 60 twice. So multiplying by 61 gets you 0.018. And multiply by 60 again gets you, that's kilometers per hour. And then multiply by 60 again is, I'll round that to 0.2. 0.2 multiplied by 60 is 1.2. So this is going to be roughly 1.2. So it's probably going to be the second one as an estimate. Kilometers per minute, thank you, and then per hour. Yeah, so as a rough estimate, I rounded things here and here and here to get our answer. I tell you what, this one has been awfully fiddly with a lot of the calculations so far. I hope it doesn't continue like that. The angle of a quadrilateral is taken in order are x, 5x, 2x, and 4x. Which is the following quadrilateral? Well, it can't be a kite because opposite. You need either the x and the 2x to be the same, or the 5x and the 4x to be the same. It can't be a parallelogram because opposite angles need to be equal. It can't be a rhombus because opposite angles need to be equal. An arrowhead looks like this, and in an arrowhead generally these two angles are very small, and then this one is very large, and then this one is not as large. However, if you look at the angles, if we work out what the angles are, it's 5x, it's 12x, there's 12 x's in 360, x is 30, so it's going to be 30, 5x is going to be 150. In an arrowhead you need a reflex angle, 60 and 120, so my guess is going to be a trapezium. And the reason it's a trapezium, in any trapezium, whatever it might look like, because these are parallel, adjacent angles must add up to 150, and they do. You've got 30 and 150 adds up to 180, sorry, and 60 and 120 adds up to 180. So I think it's going to look something like the trapezium we have here. But it's actually going to look like it's going to look like that sort of trapezium where the opposite angles, which is you don't often see them drawn like that, but you're going to have 150, 120, 60, 30 in some order. So it's going to look something like that. So it will be a trapezium based on the angles we've got. It can't be the first three for their properties. An arrowhead needs a reflex angle, so you needed to actually work them out. Yeah, meters per second to kilometers an hour is multiplied by 3.6. That would have been a much quicker way of doing it. So 0.3 times 3.6 is 1.08, isn't it? Yeah. Weirdly, I could have worked that out, but it's not something I knew off the top of my head. I just always do it manually, because usually when I get a question involving doing it, the numbers are nice enough that you can just do it manually, civilian. The net shown consists of a square and equilateral triangles. The net is folded to form a rhombicubooctahedron. Right. When the face mark P is placed face down on the table, which face will be facing up? If P is here, then either these three or these three will be these three. So my guess is it's just going to be D, isn't it? Yeah, so one kind of ring round the side. There's 4 rings from P. You've got the kind of ring here, which includes E. You've got a ring here and a ring here. I think that's right. There's a it's just got to be D, hasn't it? Because D, you need to have 3 square faces between P and the top face. and D is the only one that's exactly 3 squares away, so it just has to be D. I'm struggling to visualise how this folds up. However, to get from P, if P's on the bottom, to D on the top, you need 3 square faces around the number around the edges, so it just has to be D. The sum of two numbers a and b is 7, and the difference between them is 2. Work out the value of a multiplied by b. So a plus b is 7, a minus b is 2, 2a equals 9, so a equals 3. And then if we substitute 3 back into the first equation, so we're going to put 3 back in here. No, why am I doing 3 there? It's 4.5. So 4.5 plus b is 7, so b is 2.5. And 2.5 multiplied by 4.5 is going to be 11.25. So 11.25, I believe. I mean, you could sit there and manually multiply those out. Yeah, I understand there's different ways of doing that. Are you saying I've got it wrong, or do you just suggesting different methods? You're right. Yeah. I was just getting the number of squares from P to the top face, and there's 3, isn't there? Yeah. Well, I can visualize it from here. I'm just wondering how, like in theory, there should be a third face from here from P. And I don't know where it's coming from. I guess it's coming from those are the bits coming off B and D. Oh yes, so they join up, and then they join up. There we go. There we go. Because the two triangles will turn it 180 degrees. Yeah, there we go. No, that's how we do it. Yeah, so you don't want to know the way I've worked out 4.5 times 2.5 is I know what 3.5 squared is, and you take off 1. 4.5, so 3.5 squared, if you know that, is the same as 4.5 times 2.5 minus 1, which is just the difference of 2 squares. You can write 3.5 as 3.5 plus 1, 3.5 take 1. I'm not going to go into that, but that's how I worked it out. The diagram shows a heptagon with a line of 3 circles on each side. The numbers 8 to 14 distributed as shown, as the numbers 1 to 7 to be distributed to the remaining circles. The total numbers in each line of the 3 circles is to be the same. What is this total? 8, 9, 10, 11, 12, 13. So usually we are putting... I'm just going to play about with this. Well, let's try putting 1 and 2 there. So the total here is... might be more elegant. So the total here is 17. So 1, 13, that would be 3. 3 plus 12, that would need to be 2. That doesn't work. I do know, however, that 1 has to go with 14. There's no way 1 doesn't go with 14. Because the highest one, the lowest one will always go on the same row as the highest one. That's how these work. So that could be 3. And now the total's 18. So that would be 4. That would be 2. That would be 5. And that would be 3. That doesn't work because we've repeated 3. Yeah, this is I'm just doing it trial and error. There might be a clever way of doing this, but I'm happy to do trial and error on this. I know 1 goes to 14, so we've had 1, 2, 1, 3, so we'll try 1, 4. So this looks like a 19. 19, so that gets us 14, we need a 5. That gets us 2, that gets us a 13. We need a 13, we need a 6. We need a 3. 3 and 9 is 12 and 7. So that's how we do it. That is a possible solution. So I believe the answer is 19, and the total will be 19 from there. You can average all the numbers, but you're counting 1 to 7 twice. So you could average all the numbers, but you've got to make sure you average all the numbers whilst counting one of them twice. Well, we're counting the 1 through 7 twice, so you could add up all the numbers and then count them twice. So the total of 1 to 14 is 120. So if you know that quickly, and then the total of 1 to 7 is 27, I believe. No, it's 28. So you could just say it's 120 for the 1 to 14, and then another 1 to 7 is 28. So it's 148. And you've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6 sides. So divide that by 6. Do you get 19? No. So I've done something wrong in my mental arithmetic. The sum of the numbers 1 to 14 is, oh, it's 105. 105. And then this gets you 133, and 133 divided by 7 is 19. So yeah, that would work as well. Yeah. Yeah. I did 1 plus 14 times 8, so I was being silly. But yeah, that would work as well. So if you sum up all the numbers that you're adding, but remember you've got to count the circles twice. 105 and 128 is 133, and you divide 133 by 7. 1, 2, 3, 4, 5, 6. Yeah, by 7, because there are 7 faces. Tegwen has the same number of brothers as she has sisters. Each one of her brothers has 50% more sisters than brothers. How many children in Tegwen's family? So there is one more girl than boy, because Tegwen is a girl. So you've either got so girls and boys. That'd be a nice way of doing it. You've either got 2 girls, 1 boy, or 3 girls, 2 boys, or 4 girls, 3 boys, and so on. And I think each one of the brothers has 50% more sisters than brothers. So what you want is, after you remove one of the boys, for them to be 3 times larger. So if you move one of the boys from here, it's 2 times larger. So 1 and then 0. So we're looking for the number on the left. So it looks like it's 5. Is that right? 3, or do you need twice as large? 50% more. Oh, no, it's just this one here, isn't it? 50%. 50% more. So if I have 2 brothers and 4 sisters, that is 50% more sisters and brothers. Yeah, so it is going to be this. It's going to be this row here. We want it to be twice as big. 50% more is twice as big. So it's going to be that one there. We took 50% as a 3 to 2 ratio. You definitely do maths differently over there. I'll think of things differently. No, you're right. You are right. 50% is the ratio 3 to 2. No, but oh, so I'm doing this wrong then, aren't I? I'm doing this wrong. I am doing this wrong. It is 50. It is not that one. It's not twice as much. That's 100%. That's 100%. I need to be 50%. So we need to keep going. So we've got 5, 4, 3. That doesn't work. 6, 5, 4. That does work. Yeah. So it's actually going to be this one here. It's 11. You are right. Thank you. That's twice you've corrected me, chat. Thank you. The circle has a radius of 1 centimetre. 2 vertices of the square lie on the circle. One edge of the square goes through the centre of the circle as shown. What is the area of the square? The circle has a radius of 1, so that is 1 centimetre. And this triangle is a 30-60 triangle because... Is it 30-60 triangle? It might not be, might it? It's we can work this out. Let's not make a false assumption here. So we know that because the only length we've got is the circle's a radius 1. So we know that this line here is 1. We know that this line here is also 1, and this angle is if we can work out this angle, then we can work out the top length, and then we can square the top length to get the area. The angle's not 60. And we know that if that's x, oh, there we go, x and 2x. It's got to be twice as big. Yeah, there we go. So we can say 2x squared plus x squared equals 1 squared using Pythagoras. So we're going to have a total of 5 lots of x squared is 1. X squared is 1/5. So x is the square root of a fifth, or 1 over root 5, which is root 5 over 5 if you rationalise it, so it'll be one of them. Yeah, and that's x. So 2x, so to work out the area of the square is 2x squared gets us the area of the square, which means it's going to be 2 root 5 over 5 squared, which is going to be 20 over 25, which is 4/5. It's going to be that one there. Hi Sam, welcome. Right, if you're doing this with me or you're doing this by yourself, if at this point onwards we get any wrong, we are going to lose some marks. So at this point onwards we're not going to guess unless we know. Yeah, I could have done it that way, Turtle. That would have been quicker. How many of the, because yeah, you could just say that 2x squared is going to be that doesn't quite work. Well, yeah, you could do that. Yeah, you could say, look, 2x squared is going to be 4 lots of this. Yeah. Prime fact, how many following the positive integers are divisible by 24? Well, 24 is 2 cubed times 3. So for any of these to be divisible by 24, they must have up to 3 2's in it. So they must have up to 3 2's in it and 1 3. So that doesn't have 3 2's in it. That doesn't have 3 2's in it. That doesn't have 3 2's in it. That one does. So I think it's just 1. They need to share the same prime factors to be divisible. Okay, and there's no way you can divide any of these by 2 cubed and get no remainder, because the rest of the factors aren't even. The shaded region in the diagram, bounded by 2 concentric circles, is called an annulus. The circles have radii 2 and 14 centimeters. The dashed circle divides the area of the annulus into 2 equal areas. What is its radius? So the annulus is just a 2D torus, I guess. I've never seen that word before. Well, I have, but not to the point where I knew what it was. So basically, we want so we have that circle and that circle, and the area of the whole shape will be Let's see, that's 14, and that's, well, I'll call this R for the radius we don't know. And we want 14 squared pi, subtract 2 squared pi, to equal twice R squared pi, subtract 2 squared pi. So the area of the whole shaded place is this bit, and we need it to be twice as big as the area of the inner shaded bit is that bit. So I believe that's what we're doing. So 14 squared is 196, take 2 squares, 192 pi equals 2 r squared pi minus 4 pi. So we need 192 to equal 2r squared take 4, divide by pi, so we need 196 to equal 2r squared. Half 196 is 98, I've done something wrong here, is r squared. Wait, I've been told wait by chat, I've done something wrong. Oh, thank you. Yeah, that's an 8. That's an 8, which means that this gets us 200, 110. So 200, 200. But you get the idea. It's, yeah. So that's going to be 8. That's going to be 192, 200, 10. I mean, I was going to get r squared was almost 10. So 110 equals r. Yeah, I should have expanded this. I should have expanded this out better. This bit here. So I made a mistake with the 8. I would have got like very close to 10, but not quite 10. The sum of the areas of the squares on the sides of a right-angled isosceles triangle is 72 centimeters squared. What is the area of the triangle? Some of the areas of the squares on the sides of a right-angled isosceles triangle. Okay, so we're gonna draw this. And we'll call this x. We'll call this x, and we'll say this is root 2 x. Just using Pythagoras. And the sum of the squares of this is 72. So we know that x squared plus an x squared plus a root 2x all squared is 72. So we can say that 4x squared is 72. X squared is 24. So x is root 24, which is 2 root 3. No. 2 root 6. So we're going to go back with our triangle. We're going to get a new triangle. I've done something wrong, have I? Oh, 18. Thank you. My mental arithmetic is awful today. And square root of 18 is 3 root 2. So it's 3 root 2, 3 root 2, 3 root 2 by 3 root 2. So the area of this is 3 root 2 squared over 2, which is just going to be 9. 3 root 2 squared gets you back to 18, and then half it gets you 9. Yeah, that's not right, Sam. Some of the areas of this, you don't know if I've read this right. Some of the areas of the squares on the sides of a right-angled isosceles triangle is 72. That's what that means. Some of the areas of the squares, basically, all it's asking you to do is to sum up those squares. So the sum of the areas of those squares is 72. Yeah. Triangle's 0.5 squared, so 9. Yeah, agreed? Hi Tim, how you doing? A list of positive integers has a median of 8, a mode of 9, and a mean of 10. What is the smallest possible number of integers in the list? Right, so since 5 is the smallest option we've got, so it's got a median of 8, a mode of 9, and a mean of 10. Right, there's no way to get a mean of 10 and a median of 8 with 5 numbers, I don't think, with these. I don't think you can do it with 5, because to do it with 5, to get a mean of 10, you have to have a number larger than 10 in your data set. You could have all 10s, but to get the other two, you need some small numbers, which means this number needs to be large. And then you can't get a median of 8 with 5. If you had 6, you could do something like that. That still wouldn't get you median of 8, apologies. You could do something like 5, 6, 7. So you're going to get a median of 8, a mode of 9, and then some number here that's going to be 4 bigger than the number you need. So it's going to be 14. Does that work? No, it's going to be more than 14. Some large number here that will get you a mean of 10. So this number here is just going to be a flex spot. It can be whatever you want depending on what 5, 6 and 7 are, but you need 7 and 9 in the middle to get you a median of 8. You need 2 9s, and then you need all the other numbers to be different. With this one at the end will just get you the mean of 10. It can be incredibly large. So I believe 6 is the smallest you can do it in. So your median's the middle, mode's the number that appears the most frequently in the list, and the mean is the usual average. You add them all up and divide by how many there are. Two semicircles are drawn in a rectangle as shown. What is the width of the overlap of the two semicircles? Yes, so when you put them in, so they have to be in the median. If they're in order, what's the middle number? And if there's an even number of numbers in the list, it will be the middle of those two. How often do I practice math on this channel? It's not really a practice. I'm doing it for a YouTube video. So I do this and upload them to YouTube as these are maths challenges that pupils at school do. And I used to be a teacher, so I used to help pupils do these in class and stuff. And they're for the top level kids of their particular age group. So these will be for the top level 14 to 16-year-olds. Generally, the last 5 questions are usually pretty tough for that sort of age group. But I do it maybe somewhere between once and twice a week. I upload all the videos to YouTube, so often, yeah, once or twice a week, thereabouts maybe, until I've run out of these. I've done, well, I don't know how many I've done recently. I've done, I mean, maybe about 20 since January. Right, here we go. So, what is the width of the overlap of the two semicircles? Totes. So I think what we're going to do is imagine that is the radius, and we know the radius is 5. Oh, is this? Yeah, we also know that if we draw a triangle there, the height of this triangle is going to be 4. So we can say that the width of the overlap is just going to be Pythagoras. We can say it's going to be 3. That little bit there is going to be 3. That little there is going to be 3 because it's a 3, 4, 5 triangle. So we can say that the width of the overlap is 6. I would love that, Tim. Lovely, lovely. If you can send me those, yeah. I've asked a friend at my old school and he keeps not getting back to me. If you've got any of the, before you go, if you've got any of the maths challenges before 2015 on the website, they take the old ones away. If you've got any electronic ones from before 2015, I would love them. If you can get me hold of those with answers. I don't need the answers, but the answers obviously make the end of my thing better. We're now on to the last 5 questions. If we guess at any point here, we are going to lose marks if we're wrong, so don't guess from here on inwards. Thanks very much, Doug, the human official. I do mainly bridge at the moment, but I also play Among Us, Magic the Gathering, do some maths, and I've done some chess as well, and we play Codenames. So at the moment I'm doing quite a lot, but I will still do maths and bridge when I'm back working. So that would be great, thanks Tim. The diagram shows a regular octagon. What is the ratio of the area of the shaded trapezium to the area of the whole octagon? Well, so if you do that, and we call that x, we can work out the area of the shaded bit in terms of x, and we can also, to work out the area of an octagon, it's going to be it's going to be 8 of those, isn't it? That's 45 degrees. Can we work that out in terms of x? Maybe we need to do it in terms of the radius of the octagon. Magic is good, and Bridge is my #1 favourite card game. It's much better than Magic, but it's a bigger learning curve to get into. So I would definitely give Bridge a go if you have the time to learn it. It's a long learn, isn't it, Turtle? What is the ratio of the area of the shaded trapezium to the area of the whole octagon? The other alternative is you just work out. Can you work out? You might not need to do that last bit I did. If you just work out. If you work out the bit I've done in terms of x, which I think you can do, and then this band is going to be x lots times x plus whatever this is. So if you've got a triangle, this is what we need to do. We need to work out this in root, so in terms of root x. So what I'm looking at is this little triangle here. If that's x, then each of these sides will be, I'm going to have to work this out, y, 2y squared equals x squared, y squared is x squared over 2, y equals x over root 2, or root 2x over 2. No, the only current teacher is Tim Lister Maths, or T Lister Maths. Everyone else is either a bridge player or Amiga likes his maths, but I don't know what Amiga does. Turtle's a bridge streamer, former Magic judge. Sam is a 13-year-old bridge playing student. Ignatius is a Canadian programmer of some sort who plays bridge. It's just a bit of everyone, really. Oh dear, this is just going to be fiddly. So we are going to say that this length here is going to be an x and 2 lots of root 2 x over 2. So this is going to be, so that means this shape here, we'll call it A. A is root 2x plus x times x, which is root 2 plus 1 x squared. And then the area of the shaded section, we'll call that B, is going to be x times root 2x over 2. I should have probably picked a different number for x, plus 2 of these together. The 2 of those triangles together just make a square, and the area of the square is just going to be x squared over 2. The angles of a regular hexagon are 60, but this is an octagon. Octagon is 135. So that's going to be B. I think I'm definitely making this too complicated. Is root 2x squared over 2, root 2x squared over 2, plus x squared over 2. So it's going to be plus x squared over 2. Oh, hang on. And there you go. That is the same as root 2 plus 1 x squared over 2. So the area of A and B, B is twice as big as A. Sorry, A is twice as big as B. So that's also a B. And so this is actually 3 B's. So it's just going to be 3 to 1 or 1 to 3. Let x equals 1. Yeah, if x was equal to 1, my life would be a whole lot easier. Absolutely right. But it still worked, Turtle. If I'd have said x was 1, that would have been much easier. In fact, that's usually what I do. I don't know why I didn't do it today. I may not know a lot of maths. I think it's pretty rad. I do 3 levels of difficulty of challenge. This is the medium one of the 3. I do an easier one, which I did a few days ago, and I'm going to do a harder one next. I'm going to do the senior 2016 one next. So, in a particular group of people, some always tell the truth, the rest always lie. There are 2016 in the group. One day the group is sitting in a circle. Each person of the group says, both the person on my left and the person on my right are liars. What is the difference between the largest and smallest number of people who could be telling the truth? So you could have true, lie, true, lie, true, lie, true, lie, all the way. And that means all the truth people have 2 lies next to them, and all the lies are lying because they have 2 truth people next to them, and they're lying. And that means everyone in the circle would be telling the correct thing based on whether they're a truth giver or a liar. In that particular case, you have 2016. You have 1,008 people telling the truth. That's half of them. So you could also have, for every truth teller, you need 2 liars always. But for this liar, that could be the case as well, and he would still say, I could still say both the people on my left and right are liars, and he will be lying because that isn't the case. He's got 1 liar but 1 truth teller. And then this liar can't have another liar, because then this liar, when they say both the people to my left and right are liars, will be telling the truth, and that wouldn't work. So I think you can also have that. I don't think you can ever have 3 lies in a row, and you can't have 2 truths in a row. So you can alternate it, and then the most number of lies, you can never have 2 truths in a row, because their neighbours must be liars, which means this is a third of them. And does 2006 divide by 3? It does. 2016 divided by 3, it does. 2016 divided by 3 is, I'm just going to do it. 2016 divided by 3, 672. 672. So it's going to be 336. The difference between these two, the most and the least. Yeah. Right, 3 questions to go. What are we looking like time-wise? We're actually going to run out of time, but I've been chatting a bit, so I'm going to keep going till I'm done, I think. A Saxon silver penny from the region of Ethelbert II in the 8th century was sold in 2014 for £78,000. Design on the coin depicts a circle. That first bit's irrelevant. A design on the coin depicts a circle surrounded by 4 equal arcs, each a quarter of a circle, as shown. And what is the radius of the small circle in centimetres? So that's a quarter circle, and that is 2. That's a quarter circle, and that's 90 degrees. Oh, this is quite nice. So if that's 90 degrees, you can work out the radius of this, because it's a right angle triangle. You can say that x squared plus x squared is 2 squared. So 2x squared is 4, x squared is 2, x is root 2. And you know the radius of the quarter circles is 2. So if you've got a quarter circle, you know the radius, that's 2. So apologies, that's root 2. That's root 2. And if we can work out the height of this triangle, so the height of the right angle triangle here, from the centre to the side, we can work out the radius of this, because it's going to be, we need to work out this little distance here. So the height of this triangle, if you've got that triangle there, the height of that triangle, we've got root 2, root 2, 2. The height of this would be that'll be 45. That'll be 45, so it's 1. That's 1, because this is 1, because it's half of the length. So we know that the little length here, we know that if we call our missing width W, we know W plus root 2 minus 1 plus root 2 minus 1 equals 2. So W equals 4 minus 2 root 2. Oh, hang on. What's the radius? What's the radius? That's the diameter. So the radius is half of that. It's 2 minus root 2. Woof. Thank you, Tim. I spotted it roughly the same time. I thought it was that. When I'm looking at it, I'm like, that's half the answer. What have I done wrong? That's half the answer. Every day, Amy goes up an escalator on her journey to work. If she stands still, it takes her... We've done one very similar to this recently. Amy goes up an escalator on her journey to work. If she stands still, it takes her 60 seconds to travel from the bottom to the top. One day the escalator was broken, so she had to walk up it. It took her 90 seconds. How many seconds would it take her to travel up the escalator if she walked up at the same speed as while it was working? So, what we did last time is we assumed a length of the escalator. So if we say the escalator is 30 meters, when it's moving and it's still, well, you've said 180. Okay, well, I'll do 180 then, makes the numbers easier. I was going to do 30, but you get the idea. And then she's walking and standing. And we're going to work out how long it takes her in these cases. So, one day the escalator was broken, so she had to walk up it. It took her 90 seconds. If it took her 90 seconds to do 180 meters, she would be walking, her walking speed would be 2 meters per second. If she's standing still and the escalator's not moving, she can't do anything. The speed of the escalator is, if she stands still, is 60 seconds. She can do it in 60 seconds. Have I done something wrong? Yeah, standing still. So if she's standing still when it's moving, 60 seconds. The escalator is moving at 3 meters per second. So if she was walking and the escalator is moving, she would be walking at 2 meters per second. The escalator would be adding 3 meters per second. So in total, she would be doing it in 5 meters per second. 180 in 5 meters per second is 36. 36 seconds, 180 divided by 5. All right. The tiling pattern shown uses two types of tile, regular hexagons and equilateral triangles, with the length of each of the sides of the equilateral triangles equal to half the length of each side of the hexagons. A large number of tiles is used to cover a floor. Which of the following is closest to the fraction of the floor that is shaded black? So what we've got is a hexagon like this, and I think I know what I'm doing with this one, and we've got some triangles attached to it. Now each hexagon's effectively got a triangle here, effectively on each corner, so a triangle here and so on. Now, because this is half the length, this bit's equal to this bit, in theory, those three would be the same as that bit of the hexagon. That's how it would work. So you can see that one triangle is the same as one of these bits, and in the hexagon you're going to have 6 equilateral triangles made up of smaller triangles. So in the hexagon you've got 1, 2, 3, 4 times 6, you've got 20, you can fit 24 little triangles in the hexagon. And each hexagon in the shape has 2 little triangles. You can see that each little triangle, that triangle there, is attached to 3 hexagons. So because that's attached to 3, each hexagon is providing, on average, 2 of the black triangles to the pattern. So every time you put one hexagon in, you're adding 2 black triangles in. So if the hexagon is 24 and it comes with 2 of the little triangles, but the other triangles from this hexagon come from other hexagons, it's going to be 1/12, i.e. 2 of these out of 24, 1/12. Hey, original Ilaloka. Welcome, welcome, welcome. We're just about to mark what we've done. I think chat has pointed out definitely 2 things I would have got wrong, because I got the answer wrong, moved on, and they told me the answer was wrong. So we're going to go back to the start, and we're going to get a green pen out and mark what we've got. The problem is I can't do all the. All right, so let's get the answers up somewhere. Let's get them on the side screen. So intermediate 2016 solutions. All right, so here we go. So all the way back to the start. Remember, you get 5 marks for each question right, 6 for the last 10, and you lose marks if you get any of the last 10 wrong. Can we see 21 again? We might have misread something. Okay, we'll go back to 21, said chat, if you want to check. Yeah, I got the area of the middle band to be twice as big as the top band, so I think it's 3:1. If I get it wrong, it's fine. It's fine. I will mark it I'll give it a go. So question 1 is B. Got that right. Question 2 is D. Question 3 is also B. Question 4 is E. Question 5 is A. That was a chat one. I misread that question. I would have got that wrong if I was doing it properly. Question 6 is C. Question 7 is also C. Question 8 is E. Question 9 is C. Question 10 is E. Question 11 is D. Question 12 is D. Question 13 is B. Question 14 is D. Question 15 is A. Question 16 is B. Question 17 is also B. Question 18 is C. Question 19, not on green pen, oof. 19 is B. 14 wasn't 5. 20 is D. I'll go back in a sec, Ignatius. 21 is A. We got that wrong. Oh, yeah. It's 3 times bigger, but the ratio is 1 to 4. So we did the maths right. I just got the answer wrong at the end. So, boo. Well spotted. Semicircle bridge. B is twice in the whole octagon. Yeah. I got it wrong. So that's 3. That's 1. But B is 1 to 4 because it's 1. It's not shaded to unshaded. It's shaded to the octagon. So I got that. I got the maths right, and then I just I see 3 to 1. 3 times bigger. Done. So Semicircle bridge. You can have some bonus points for not getting that wrong. 22 is E. Question 23 is B. Question 24 is C. Question 25 is D. What have I done wrong? Oh, I've done it again. This is a ratio thing. It's 1 to 12, which means the fraction's 13. So I got that wrong. Again, I did the maths right. For every 24 you get in the hexagon, you get 2 of these. But it's what fraction the whole thing's shaded, not what fraction of the hexagon is made up with the shaded triangle. So that again is just me. That's 2 ratio questions I got wrong there, that the maths was all right on, and then I've just put the right answer in. So I need to go and check. You said question 14 I need to check. $14 wasn't 5 now. 14 is 11 kids. Tegwen sees the same number as brothers and sisters. It has to be 1 more girl and boy. And then of the 4 boys, of the 5 boys, each of them sees 6 girls and 4 boys, which is the ratio of 3 to 2. No, because the boy doesn't see himself. Yeah, but the boy doesn't see himself. So in this case where you've got 3 girls and 2 boys, one boy will see 1 boy and 3 girls. So they won't see themselves, which is the issue. No worries. Right, so we get a score, and we don't do so very well this time. We got all 15 of the easy ones right, with an asterisk that I was corrected on some of them. We got 8 of the hard ones right, the 48, and then we got question 25 wrong and question 21 wrong. So we've got 2 of the hard ones right, so we lose 4 marks. 2 lots of -2 is -4. 75, 123, 119 out of 135. All the maths was right, and basically at the very last second I did all the maths right, and then I put the wrong answer in. And then exactly the same here, we did all the maths right and put the wrong answer in. And I misread 2 questions, but chat was very helpful. They definitely pointed out some of the mistakes for me. I hope you enjoyed it. I found the start of that quite finicky. There's quite a few like long-winded calculation questions that we were doing there. What was the other one you pointed out to me? as something I got wrong. You pointed that one to me, and there was another one you made me go back and change. I can't remember what it was. Oh, it was this one, wasn't it? So that was also a chat. So chat wins that one. Right. So we're going to call that a day. If you want to watch more of these videos, please subscribe to YouTube. I will do them live on Twitch. So if you go over to Twitch, the link's in my description at the bottom. If you all want to have a go at these in the future, pause the video at the start, download the paper from the link I give you, and have a go, and then post what score you got. Did you beat? And it beat definitely a beatable score this time. Did you beat 119 out of 135? Can you beat that? Can you post that? Let me know which questions you like the best. And I will see you for the next one, which will be the senior from 2016.